We actually took this to Scrubgrass today and were able to round up a 20-foot section of wall. Unfortunately, that'd be much too cumbersome and heavy to bring here tonight. This small section that we have here is around 78 pounds in itself, so sorry, but it'll be just a little bit of a taste of what this dock can do. As you can see, our magnets are quite strong, and there's really no concern of it falling off the wall.
Rolling, yes, falling. Okay, ready?
Unfortunately, because of space limitations, that's as far as we can actually see. As you can see, it does go up. When you have a longer section of wall, we can get it going more than 2 feet a second. So it does slip along pretty well.
Okay. Brian also wants to show off the camera because this thing is incredibly powerful.
I just pulled it.
Yep. So the camera needs a minute to boot up.
We're very impressed with our image capability here. It's a nice, crisp HD image. And see, we can also.
So the idea is that we can actually, they can look at the pipes. Let's see if I can get it.
Spray paint so it's coming out like
So there'll be a whole wall. It'll all be extended up here. You'll be able to see dozens of pipes and see if there's any flaws in them. And then they could also whip it around and look at the other side of the boiler or any walls around it.
Do that, but let's do that without turning the lights on. Don't do that.
Any questions?
You made the assumption that the interior of the pipe wouldn't have any sort of deterioration. Could you validate that with your client or customers?
Yes, they chemically treat the water to minimize corrosion. Corrosion control is fairly well known. The problem is that they're using a fluidized bed boiler, which includes a lot of silicates in the coal that they burn. And because of the amount of air, you basically have the exterior of the tube being continuously sandblasted 24 hours a day, 7 days a week. So every 18 months they have to do a shutdown where they go through and evaluate the thickness of the tubes and repair the ones that have been worn away. So internal corrosion is known and minimal. External corrosion is variable and serious issue.
Can you track this over time? So, in other words, to be able to get the reliable data on how long these pipes will last inside the boiler?
Once the analytical system is up and working, then we would be able to do more of that in the year cycle.
Well, if you're allowed into the boiler at regular intervals, we deal with that times, but it's really hard to get inside a boiler. It runs as often as possible. It's every
2,500 degrees.
Every 18 months, so
we could do
the force shutdown trend then, say over time.
What we are hoping to do is if it shows that they don't need one every 18 months, then they can put off those shutdowns.
I guess that's what I'm thinking, that you could save all that by proving that you're able to improve this much.
The issue is that it's a fluid system, and there's so many unknowns that small variables will cause areas that you didn't anticipate to experience more erosion than they normally do. So you'll have times, the particular application that we were hoping to match here is in the event of a forced shutdown, where a patch wears abnormally quickly, and they have to shut down for that particular repair. This would be able to verify the integrity of the rest of the tubing and allow them to postpone a planned shutdown in the near future by being able to say that we fixed the problem, we don't have any other problems, we can push that out further.
I think I remember in past projects and such that localized erosion is a big issue. Is it going to be an issue that you might not be able to do detailed analysis of the, say, the top foot of the boiler or the bottom foot of the boiler?
Well, yeah, the first approximately 15 feet are covered in a refractory plaster, so those don't experience much corrosion. The first several feet will be where people will be standing. They'll be able to do a visual inspection on that. What we're particularly worried about is that to scaffold the interior of the boiler, which is the only way currently to get to the top, the upper reaches of it, is extremely expensive, close to $250,000 to scaffold it. So the idea is to be able to send this in and verify the integrity of those upper reaches and not spend all that money to scaffold it, just to find out, yeah, good tube up there.
And we put the lasers as far in front as we could so that we get to the variables as much as possible.
Do you anticipate marking with the paint based on the laser system or based on what you see with the camera or both?
There's going to be an automated response to the quantitative part, and then also the manual. So both good.
I'm just curious, so with the Xbox controller, there's, you can map any of the other buttons to, I'm just curious if you knew, like, whatever, if you had any other functionality that you progress would add to the robot, like any other features you had in mind to add to it? If you had time.
Well, this afternoon, we actually got a chance to go to the scrubgrass plant, and they had a 20-foot tall section of wall for us to drive it on. And we initially thought that the worm gear drive in the motor was going to be enough to hold it on the wall when we stopped it. But the gear ratio is small enough that it actually back drives the motor under its own weight. So we actually want to incorporate a brake that'll actually clamp down on the shaft when we tell it to, and we can program a button to do that just by using some coding and a relay inside of the control box. Jim or Jeff also had an idea of putting a flame spray gun onto the robot to flame spray the inside of the boiler, and potentially it could be used for that too. There's any electrical device basically could go on there if the wire voltage is curved.
More questions?
Just as a side note, we're taking this to another boiler next week that's actually offline. They're really eager to look inside, and it's been a problem in the industry for 20 odd years. So this is one of the first times anybody's actually done it, mainly because it's such a difficult project to do commercially. So using the college guys, this has turned out great. I gave it to my boss, he gave it to his boss, he gave it to his boss. So we got some real kudos from Grove City, just the design team in general. Everybody was impressed with it. So. And we will make it faster, bigger.
Yeah, you have close to 100 pounds of payload capacity after you remove the weight of the robot from the extractor power. So you almost, if you had enough motor power, you could quite literally take a small person off the wall.
And this is definitely a first iteration that we wish we had more time to improve upon, but fortunately that'll have to be up for somebody else.
All right, we're done?
Yep.
Yeah,